I guess the theme I'm really trying to develop here is that the explorer and the lab liaison is really vital at all stages. And both parties really need some basic understanding of what the other groups do so that you can get the best out of the whole experience with the lab and with your results. Don't forget that commercial labs generally are quite large-scale operations, semi-industrial processes, looking at sort of tens of thousands of samples going through, lots and lots of methods, probably something like 40 routine methods, but there's hundreds of others that aren't necessarily advertised that may be of use to you. Generally have lots and lots of employees. Turnaround times can vary as well. Clients can occasionally get quite upset about turnaround times, but that can really vary. It depends on the type of work in a lab at any particular time. You can see that on the bottom there, you can actually get through 10 times more lead collection fires than you can nickel sulfides. And depending on the work that comes into a lab at any one time, the turnaround time you may have been given may blow out if there's big jobs with different sort of methods coming in. One exception to me saying that the labs are usually large scale is Lab West here in Perth, which is really a small boutique lab which does mainly concentrates on microwave digestins and other things, as we've heard from Ryan this morning, looking at the ultrafine work. Whatever the size of the lab, I strongly suggest you do a lab tour, get to know some of the people, get to know some of the processes so you can really understand where they're coming from. From an explorer's point of view, please remember that your job's not the only one in the system. You might like to think it is, but it's not. So try and keep things as simple as possible, quite straightforward. And from the lab point of view, try to understand what the client really needs. And what they need may not be what's on the submission sheet. No one wants to see a whole list of numbers where a job, they're really after low-level bismuth, they'd chosen the wrong method, they went for OES, they got a whole list of less than detection limits. Doesn't bode well for anyone. The client in this particular incident claimed that they were sold the wrong method. The lab claimed that the client didn't make it clear what was going on. And we find that in labs these days, most people there's at least one or two geologists, if not geochemists in labs. So try to get to know somebody with technical experience so that they can be your champion in the lab, so the two can really work together. And hopefully that geologist or geochemist can actually put the analysis into a bit more context, so you are actually choosing the right method. I'd have to say that person may not always be the person you've dealt with as far as giving quotes and things. Try to get to the right person in a lab that has the technical expertise, and they might not know everything about every particular method, but they will know who within the lab is the useful one to talk to. At the early stages even, that understanding what happens is worthwhile. Batch sizes, send in a submission of 3,000 samples, that will be broken up into different size jobs. And they're method specific. So for jobs that take longer to do or larger sample sizes, you'll find the job sizes vary quite a lot, from quite small down to sort of 60 or so up to well over 300. I certainly like, when I'm submitting samples, to have some idea what the job size is going to be. It may mean that I want to put samples from a particular area into one job, so I get those results back at the same time. And certainly I'd like to keep field duplicates together rather than having them split off. Therefore you run the risk of even sort of more inter-batch variation, so try to avoid things that you do have some control over. Of course, there's sort of regulatory constraints. You may have to have quarantine samples, which means they go through set drying temperatures. Anything that's asbestos or uranium work obviously has to be labelled. Certainly high and low-grade samples, it's best to tell the lab and not mix them up, not only from a contamination point of view, but also an analysis point of view. For high-grade samples, don't choose a low-level method thinking that you've got a bigger margin between an advertised detection limit and your sample. All that's going to do means that they're going to come back over range outside the calibration solutions. You're going to actually end up with worse results, not to mention contaminating the circuit in the lab and not making yourself very popular. So choose the right method for the work you're doing. Prior to submission, keep your numbering as simple as you can. Careful if you're using prefixes and suffixes, they can often get lost. Certainly try barcoding or any other tracking method that you can. And be very wary of packaging. These are all examples of samples that have actually turned up in labs to be analysed. You can see that clearly packaging wasn't too flash in most of those cases. Calicos can leak dust, and plastic bags don't contain wet samples very well. And even when you think you've done the right thing, package them nicely in plastic bags, put some cardboard over your pallets so that they all look good. The nails have worked through the pallet in transit and nicely punctured all the bags. Certainly cardboard boxes aren't very good for transporting chip samples. They can go through. Flimsy outer polyweed bags aren't much use either. They've deteriorated in transport. But luckily most samples arrive looking nice like the bottom example there. Many processes go on in sample prep. I've listed some of them there. Certainly drying will be common to most of them. You may not do some of the other processes. The other one that's likely to be pretty common is pulverising. One thing I want to mention there is to be both manual and robotic prep available in many labs. Be wary that if you're using manual prep, it's usually one operator will work on either 2 or 3 mills. And that's important if the client is deliberately putting in a blank sample to check out for carryover after a high-grade sample. If the operator's working on 2 mills, that second sample will actually go into a different mill. So it won't be monitoring what you want at all. The blank will come back, the mill wash will come back nice and clean, so you think you're home and hosed. In the meantime, it's been done in a different mill, and the sample, you've got no idea about the samples that have followed the one that you had an issue with. So know that in advance, set it up with your lab so you know what's going on, put the samples in where you want them. Generally with robotic prep, you'll do a mill wash after every sample. They generally aren't analysed, but they're available. And so in some cases you may not want that iron ore, for example, you may not want that mill wash. So again, you'll need to liaise with your lab to look at that. After that, the labs will take about a 200 gram sub-portion out of that to be the analysis portion. They'll depending on the instructions for the client, keep the coarse material and the bulk material or discard it. So make sure you give appropriate instructions for that, or else a whole lot of material builds up in storage, generally at costs. Also, think about the mill capacity. Again, if you're, as an explorer, trying to do the right thing and putting in chip standards to actually monitor how the pulverising is going, if you're submitting sort of 3 kilo samples as your main samples and only a small amount for the chip samples, because you bought these standards, they'll actually be done in a different mill. It's not appropriate to do very small sizes in large mills, so again, you're not monitoring the way you had intended it to be done. Also be wearing again a high and low grade. Try not to mix up high and low if you can, just reduces contamination. Okay, it's not always possible, but anything you can control, try and make it as simple as possible and as easy as possible. There's lots of other things can go wrong, so try to, as Simon was saying, the luck factor, try to control the things you can, therefore you can have a better way of recovering from others. So, apart from neutron activation, we generally need to get a solid sample, which is our pulp, into a form so the instruments can read it. And in many cases that's a solution, and acid digestions are the common way. And although there's many types of acid digestions, the most common ones are aqua regia. One thing I'd say there is, although the traditional definition of aqua regia is a 3:1, hydrochloric to nitric, that's not always the case. Various labs have different versions of that, and they also run them at different temperatures. So you are going to get variations between labs depending on whether it's a harsher or a less harsh aqua regia digest. Also common is 4-acid digest, and that's what most of the large multi-element suites use these days. Certainly there are other acid digests, single acids or multiple acids, and Richard will be talking a lot more about this later. Microwave acid digests are actually, again, using a combination of acids, generally have fewer steps than the standard hot plate ones. You can see on the bottom diagram there, they're actually in pressure vessels into a microwave unit, generally a lot quicker than the traditional hot plate digests. And various other things you can look at also for horses for courses, cyanide leaches where you're looking at for blade work for low-level gold, and partial extractions where you're deliberately only dissolving of different fractions. And Richard will be mentioning a lot more about all of these things later on. I should just say on that the Lab West we mentioned before, they're the only commercial lab really in the world that's actually doing microwave digest is their dominant acid technique, and have really developed a lot of expertise in that. Fusions are also a traditional decomposition method, whether we're looking at fire assay, lead collection for gold, platinum, palladium. We also might be looking at nickel sulfide, which you'll need if you want to do the full suite PGEs. Both of those then involve a chemistry step after that, so you've got a solution being presented to the instruments. You can also look at alkaline fusions, and again you do your chemistry steps. Alkaline fusions will generally give you a more complete, a much harsher digestion compared to acid, and Richard will talk about this as well. Also lithium borate flux you can use as a fusion. You may want to do some solution chemistry on that and present it to ICP, or you may use the fused disc for XRF. I should have mentioned, I probably noticed that there's different sample weights that you need that are actually used in these digestion processes. It's not all the same. Some of them are as low as sort of 0.1, 0.2 grams. Others are obviously quite large, 50 grams for fire assay, 30 grams, 50 grams. It's nicely summed up with the decomposition methods from a slide from the Genesis price book, where they're looking at methods for different materials. If we look at instrumentation as the next part, XRF, you're dominantly looking at majors, minors, and your commodity elements for XRF. ICP OES, we're looking at majors and minor elements. AA is still a great technique, although dying breed these days, for gold and base metals. Copper and sulphur is generally done on an induction furnace. And of course ICP mass spec is terrific for trace elements, a whole range of trace elements and a wide range of concentrations. There's certainly been significant advances in ICP-MS technology over the last 5 to 10 years, certainly in reducing interferences, and also the machines are now able to handle higher total dissolved solids, so are able to get better sensitivity, better detection limits, mainly by the use of collision and reaction cells, so they actually get rid of some of the interference that have been a problem. And just in the last year or so, what's commonly known as triple quads, so quadrupole magnets. It's actually a misnomer. It's actually only two, but they've got one before and after the collision cell, and that's been a really big improvement in actually reducing interferences, so much so that arsenic and selenium, which were always a bugbear on ICP mass spec in the past, are actually now pretty good. They're now, to my knowledge, there's not one at the moment in a commercial lab, but I certainly think there will be. Sorry, there is one, corrected. So I certainly think there will be in the near future, and there already is. Future is here. High-res mass specs are another option, but again, I'm pretty sure there's only one of those in operation. It has been for some time. It's in Canada, in a commercial lab that is. Terrific resolution, but pretty expensive and fairly finicky, so I can see the triple quads as being the ones that will actually take over from that. Nicely summed up here by Genesis. Sorry, I think I said Genesis on the other one, decomposition, that was ALS. Genesis is the methods to use. Comes from their price book, you can all access that. Nicely summed up by BV slide, and Alex will be talking more about laser ablation after this. Be wary of some limitations as far as decomposition. Not all minerals are dissolved, and Richard will talk about that, and if they are, you may actually lose some things, either going up or down, volatilising or precipitating. Some samples aren't suitable for various methods, reduced samples, sulphide and carbon-rich ones especially, and we've talked a bit about instrument readings. To some extent, every decomposition method, or at least most of them, are a bit of a compromise. The things you might do to dissolve more minerals out may run the risk of losing more in volatilisation, so it is a bit of a compromise. Not every method is going to do everything perfectly. Terminology is something that does vary between labs. Duplicates usually mean a second portion of the pulp digested and analysed as part of the same job. Repeat may mean that, or it may mean that it's actually been digested as part of a different job, usually on the basis of checking results. Reanalysis usually means just another solution pass. So in fact, if you had a sample mix up at the digestion stage, rereading it is just going to give you the same wrong answer. And the reread is just through the solution. So again, you need to understand what's going on. Detection limits is always a bit of a thorny issue. And I think it should be meaningful level of detection, level of quantification aren't very useful. Reporting limits, where it's based on actually long-term analysis of blank sand samples, is what's useful there. Quality assurance, you want to work out what samples are actually monitoring what. I should say that QA, QC are usually lumped together. They're actually different. QA is the part where you set it up, and therefore then you can look at your results in the QC section. I'm the one that stuffed up the timing here, so I'll really go quickly. Quality control is pretty well in the reverse order of where you put the samples in. These are the sorts of samples that are monitoring what you're looking at. And again, I won't be able to go into this detail, but what I like to do is actually get information from the labs in how things were actually run, the run orders. So then you can put it back into some context. Here you find that I've actually, when you put it back in, you see that the first sample in the rack was being contaminated. If we didn't know that, then there's no way we could pick that up. If you're actually looking at something that was easily, you may have picked up something, a periodic problem in the first samples where they were nicely ordered, not in the last 40 where the samples in racks were all over the place. Bit about how I like to break up jobs. We won't have time to go into that. Certainly if you want more information, all the labs' price books and catalogues, websites and things have useful information. Scott Halley's website certainly gives you good information, and SDS put out a good guide some years ago that's worthwhile, although I won't have some of the really brand new methods in it. Okay, I'll now hand over to Richard, who will elaborate on complete and incomplete digests and where partials fit in. Richard from Geoanalysis.